building not replaced last year. All right, there you go. Write down the essential question. How do you evaluate a limit with direct substitution? So today we're doing this more the analytical way or the geometry way, or sorry, the algebraic way. Okay. Okay, so we're going to talk a little bit more about limits again today. So far we've covered how to do this numerically, how to look at it on a graph. Now we're going to do this analytically, which means basically we're going to use the algebra and the calculus piece of it. We're going to do this today and tomorrow. Okay, so just because we've got an assembly tomorrow doesn't mean you don't come to zero period. Zero period is valid, right? Because we aren't setting up or tearing down. Zero period we can make it to. Okay? So we are going to have a lesson tomorrow. I know, we should be. Okay, go ahead and write that down for me, please. It looks like you have to fill in a few blanks and fill in the notation in the middle there. Okay, you are listening now, okay? So we can evaluate limits with what we call direct substitution, okay? So what this basically says here is if we are given the limit as x approaches c of f of x, we can take the c and plug it into the function, okay? We say that these well-behaved functions are continuous at c. There are a few times when that doesn't work, okay? We might need to do something first, like maybe factor. Okay, we're going to see that here in a little bit. Actually, no, it doesn't look like maybe we don't see factor today. A factor comes tomorrow, okay? So we're basically looking at the properties of limits today. So go ahead and write down, oh, you don't have to write them down, they're there for you, right? Yes. So if you have, so it says b and c are real numbers. So what that means is this is a number. So the limit as x approaches some number of a number is just that number, because there's nowhere to plug in an x. Okay? It'll make sense when we do one. Okay? All right. The limit as x approaches c of x means I take c, plug it in there, and it's c. Okay? The limit as x approaches c of x to the n, I plug the c in there, it's c to the n power. So let's look through example 1. It's going to have one of each of those. Okay? So basically you're plugging this number down here in for the x. Okay? So is there an x to plug into in the first one? No. So the answer is 3. I told you, easier than math analysis, right? Okay. All right. You didn't believe me, did you? All right. So plugging that one in there. What is our answer to that one? -4. Okay. All right, this one I'm taking and plugging in the 2. So you've got 2 squared, which is 4. Now, on your homework, obviously you're not just writing down the list of answers. You need to practice writing this notation out. Okay? The notation piece is important that you're writing that properly. All right? Because again, we practice the handwriting all year because at some point it's not Mrs. Ballard grading your handwriting. Okay, the AP graders are not going to guess what you mean. Okay, so you have to make sure your notation is correct. All right, looking at the next one. So it looks like I actually have the picture there. Let's go ahead and put that on your calculator. Okay. I know you don't have a picture, so you're going to look at it on your calculator. Okay. So everybody grab your calculator. Apparently, mine's not up and going yet. So you guys get that function typed into your calculator and make sure I have the right function on the picture. Okay. All right, everybody has it on their calculator? Does it match mine? Yes? Okay, so I have the correct graph there. All right, it says on this one we're supposed to use the graphing utility to graph the function and visually estimate the limits. Okay? All right, so if what is my limit supposed to be approaching on this one here? So we're going to go -2. Oh, now my calculator's up and running. It's going to take a second to go through that now. All right, so right now on your graph from yesterday, look at the limit for -2 and 2 and see if you can think about what it is. Okay, well, I'm getting this to come back up. -2 and 2. All right, so as we're approaching -2, what does it look like the limit is? It looks like 0, right? So I'm going to kind of tentatively write a 0 there. We're going to calculate it here in a second. This one here, as it's approaching 2, it's kind of tough to tell, isn't it? It's really tough to tell, right? So unless I went and I evaluated on the calculator, it's tough to tell. So what I'm going to do is I'm going to go ahead and plug in. Okay, so let's try plugging in and see if we are actually correct. So I'm going to plug into this thing here. So let me get rid of that 0. That was just a temporary. So we think it's 0. Okay, so I'm plugging in -2. -2 squared plus 2 times -2. What's -2 squared? 4. 2 times -2. Answer is? So were we right on that one just by looking at it visually? Yeah, the other one was a lot tougher to tell. So let's try that one. We've got 2 squared plus 2 times 2. 2 squared is 4 plus what? 4 equals 8. And that looks about right. We know that the top, my calculator is showing that the top is an 8.94. So it was somewhere way up there, but it was really hard to tell where it stopped. Okay? So using the analytical method by plugging in or direct substitution gets us the exact value of it. Okay? Without having to try to guess it off the graph. On the test, yes. Okay, so and on your homework you need to write that out. It's nicely written in your notes for you, but you have to write that out on your homework. All right? Okay, this one was there. Oh no, I didn't make you fill in here either. Boy, these are like the lazy notes. Okay, if P is a polynomial function and C is a real number, okay, so basically instead of just having an x, if we have a polynomial like x squared plus 5x plus 2, we've actually did this in the last problem, we can take and plug that in for any, plug the number in for any of the x's, okay? Same thing goes if I have a fraction or a quotient, okay? We plug in the, whatever that C value is or that number is for the top and the bottom, for whatever x's are there. All right, so basically, plug into x. Okay, can we handle that? Yeah. All right, so let's plug into x. We've got 4 times 2 squared plus 3.
So you plug in the bottom number to the x?
You plug this number in, yes. Okay. That's the C value. You don't, it's just what, you don't have to even remember that it's C. It's just that whatever that number is, you plug in for the x. All right, 2 squared. 4 times 4. 16 plus 3 is 19. Again, you're in AP Calc. We can do some of the arithmetic part in our heads. Okay? Are we good? Sage, you okay? You're good? Okay. You're stunned at how easy this is, right? You're looking forward to the next test. All right, let's plug this one in. I figure, not sort of. This is as good as it's going to get. I need keys for you. I'm assuming you want your notebooks.
Yay!
Your stats notebooks are there. You might want to go get a card. I stole the one from in front of Jessica's desk when I did it. Oh, and then there's some math analysis ones there.
What box is that?
So. Yeah, I'm dying. It's like, because I put jeans on, because I have to pick up children from school today.
Yeah,
and there's no air running in here. This is the worst day ever.
Out in public.
Yeah, yeah. Okay, so -1 plus 2 over what?
Over
-1 cubed.
-1 cubed. All right, so what's -1 plus 2? 1 over -1, so our answer is -1, not 0.
Oh, my bad.
Okay. All right, let's keep going with this. So when we're talking about these, you notice these things are all called theorems, right? Way back in the day when you took geometry, and technically you did those things called proofs where you proved the theorems. Sometimes in your college calc class you might do that. I don't prove any of the theorems in here, okay? Because I teach you how to use the theorems. So basically for every different type of algebraic expression that we have, they have a theorem with limits. So obviously it's the same idea, right? Whatever that function is that's there, we take the x value and what do we do with it? Plug it in. Okay, so each one of the theorems is saying the same thing. This one is saying that the c value has to be a positive, okay? In theory, it should be, well, for a radical, it has to be part of the domain, so it needs to be a positive number is what they're saying. We don't, remember how we had i's last year? Yeah. We don't have i's in calculus. Okay, so if you're getting a negative under a radical or an I under a radical, that one doesn't work. So you do the complex numbers in here, okay? All right, does yours say 14 or 4? No, it says 14. Okay, awesome. So what do I do with that 14? Plug it in. So we've got the limit as x approaches 14 of the square root of 14. I shouldn't have written that part out, should I? Sorry. Miss Dudley messed me up. We'll blame her. Square root of 14 minus 10. Square root of 4, which is 2. Again, really, really hard today. I know, almost impossible, right? Okay. Let's keep going. So this one is talking about function composition, okay? So the same thing goes here. Basically, whenever we have a function inside of a function, we find the limit of the inner function and then plug that into the outer function, okay? So let's talk about those in this problem here, okay? So notice all of the limits, well, they're not quite all going to the same place. So this one here says we want to find the limit of f as it goes to -3. So what am I plugging into the f function? So -3 plus 3 is what? 0. So that first limit's 0. Okay. And then we're plugging the 2 into the g function. So what I'm getting 2 squared, which is what? 4. Okay, now remember that when we have function composition, I take this and I plug it into the f function first, right? So let's talk about, what we're really looking for is g of f of 1. That's going to get us the limit. Okay, I'm not going to write this out the way I did last year. I'm going to kind of write some scratch work. I take 1 and I plug it into here. What's 1 plus 3? I take that 4 and now I plug that into the g. Does that make sense? We did this last year. I know we only covered it really briefly, but we did it last year. We're going to take 4 and square it, and we get what? 16. Perfect. I know. But then you look at it on your homework and you freak out, right? All right, so go back and watch the video then. All right. Okay. Whatever works for algebra also works for trig. Okay, we don't get to hide from the trig. We do it pretty much every day. Again, whatever this x value is, you plug it in for the x, okay, and you find the limit accordingly. Okay, so let's try this one. And this is why unit circle is important, because it comes up quite a bit on this little piece here, with any time we do trig. So what am I plugging in for the x here on example 7? 0. Okay, so if I'm thinking tangent of 0, remember tangent is the sine divided by the cosine. I need that coordinate right there, right? So what's my sine? 0. What's my cosine? 1. So my answer is 0. Ruben, write this down.
Yes, ma'am.
What?
Kale smells terrible.
Well, then why are you drinking that? I've survived this far, never had a piece of kale in my life, so... Three kids later, I'm good. I don't need kale. Okay. So, just wear a toga over jeans. You'll lose weight. I think I'm going to sweat off 5 pounds today. Okay, I'm plugging in the pi. So we've got pi cosine of pi. All right. So we've got, this is the pi coordinate, right? And remember, it's cosine comma sine. So what is the cosine of pi? -1. So we've got the answer is negative pi. All right, we good with example 8? Okay. Okay, so this one you got to think of just a little bit differently. Whenever you see trig and we write that little fancy squared on there like that, think of it like this. Sine squared like that on the outside because you want to square your final answer. What am I plugging in for the x? 0. Okay, so I'm back over here at this coordinate. What's the sign of 0? 0, right? So 0 squared would be 0. It's great when we do a lot of work and we get a 0 for an answer, isn't it? That one wasn't even that long and we got a 0. Sometimes they get longer. Okay. Last little bit of this. All right. We've only got one set of properties and one example left. Okay. All right. There's nothing for you to fill in on this one either, is there? Boy, I was way too nice on these notes. Okay. So, basically this is giving us all these other properties of limits. So, if we have what we call a scalar multiple, you've got a number in front of your function that you're multiplying by your function. It's that number times whatever the limit of the function is, okay? If we have two different functions, we're allowed to add their limits together. If we're multiplying the functions, we multiply the limits together. If we're dividing the functions, we divide the limits. And if we have a power, we can take that power to the limit to that power, okay? Pretty much that would be common algebra sense, wouldn't it? Okay, so that's really what that, but officially it's a theorem. Some guy somewhere along the line got credit for that theorem. Not enough credit to get his name on it, but he got credit for that theorem. So on this one here, notice, it didn't give me a function, right? It gave me two generic functions, but it told me what their limits were. And we're going to apply the properties, okay? We'll do this a little bit here in calculus. So basically this is saying take 2 and multiply it by g's limit. What's g's limit? 6. 2 times 6 is 12. So far we've done like, I don't know, 3rd grade arithmetic today, okay? All right. What am I supposed to do with the two limits in B? Add them. So 9 plus 6 is 15. Okay. What are we supposed to do with this one? Multiply them. 9 times 6 is 54. All right. What are we supposed to do now? Oh, no, we might have to simplify a fraction. All right, we finally got to math my 3rd grader doesn't know how to do yet. Okay, so 9 over 6 is what? 3/2. Technically in AP Calc, do I have to simplify? No, I could leave the 9 over 6. All right, this one here is technically a power, right? Because isn't the square root power the same as to the 1/2? Okay, so, but do I have to write it as that? We've got some nice numbers there, so couldn't I just write it square root of 9? What's square root of 9? 3. Can we handle this homework? Okay. So, all right. Glad we can handle it. So I did post it in Haiku. It's also here at the end, I think. It's homework 9. You're going to do page 67, 1 to 39 odd. I believe that's posted in Haiku. I did it really quickly early this morning. It is. Okay? So, you have a bunch of time right now. Okay? You can either grab a book from the front or use the online book. Okay? So, Amador, if you look at go to the welcome page. Go to the very top of that, the top tab on there. The welcome page. The very first, on the left side there. On the grade left side, the very, very top, it says welcome. Yep. So, and you'll notice how I always put the section numbers. You can always go to it doesn't have like the reading part of the book, but it has the problem.